Okay, so this session's day 7, and it is about Earth and space. We're continuing on with that. So when we look at question 1, it says, an astronomer, well, let's look at the question. It says, what is most likely object number 3? And object number 3 is right here. So an astronomer observes several items in the night sky and writes down their distance. So I've got, 60 million light years from Earth. That is a long time, traveling at 250,000 miles per second. That is really far away. If the center of the Milky Way galaxy they're saying is 5,000, then 10,000 would be the other side. So this thing has got to be outside of our galaxy. So it's another, I'm thinking it's another galaxy out there. Okay, we know it's not a planet, probably Jupiter or Saturn, because it's too far away. A nearby star, well actually this is the closest star to us. This is Proxima Centauri, is 4, sorry, this writing with this mouse is really hard. A comet, that's within our own solar system. So I'm going to go with another galaxy as 60 million light years away. That is really far away from us. Using the chart in question 1, what is most likely object 2? So that's here. And we've already talked about that is within our own Milky Way galaxy, because the center of our Milky Way galaxy is 5,000 light years away from us according to this chart. So if it's only 4.2 years away, then we are dealing with a nearby star that's relatively close to our own solar system. Venus would be pretty close to us, certainly less than a light year away. It would be in minutes. If our sun is 8 minutes away, Venus is going to be less than that if we're traveling at the speed of light. A black hole near the center, well, that would be 5,000 according to this graph. Another galaxy we've already identified is 60 million. So the best answer choice is going to be a nearby star. Number 3, the following picture is the Horsehead Nebula, and I know that nebulas are where stars are born. Okay, so what's most likely occurring in the nebula? And this is where stars are made. So I know that. So the birth of new galaxies? No. Star explosions like supernovas? No, but they actually, a supernova can create a nebula. So, but it doesn't go in reverse. Nebulas don't create star explosions. Formation of black holes, no, that has to do with the star dying. And so nebulas are all about stars coming together and creating new stars. The stars we see at night are in our galaxy. There's only one star in our solar system, and that is our sun, and we don't see that at night. In galaxies other than the Milky Way, they're too far away from us. We don't see them in the night sky. Both A and C, no. The best answer choice is Milky Way. We do see other stars in our own galaxy, but not in other galaxies because they're just simply too far away. Here's the HR diagram, and that's what we use to classify stars. So number 5 says, what type of star did she discover? Well, it's very hot, but not very bright. And I'm looking, and I know that luminosity is brightness on the y-axis, and on the x-axis, I'm decreasing temperature. So I'm going from hot to cooler, and of course we are still talking about stars, so even cooler stars are still very, very, very hot. But we're dealing with a star that is very hot, but it is not very bright, so it's going to fall somewhere in here, and indeed those are the white dwarfs, and that is your best answer choice. A red giant would be cooler and very, very bright. A young star in the main sequence is going to be around here, so it's going to be very bright and very hot. An old star in the main sequence is going to be cooler and not very bright, so your best answer choice is a white dwarf. Our sun is a middle-aged star with an average temperature and brightness. What type of star is our sun? Well, average temperature, average brightness. I'm dealing with a star that's in the middle of the main sequence, and that is exactly what our star is. As a normal average-sized star, so I'm dealing with an average-sized star, progresses through its life cycle. What change will it undergo? Well, as stars move through their life cycle, we can see they start out with their hydrogen converting to helium in nuclear fusion, and so they're putting out a lot of heat. And as that hydrogen converts through that process, and that hydrogen ends up converting into helium, and now you have very little hydrogen left, the star will actually begin to lose heat because the fusion is dying down. So the answer is it becomes cooler. Stars don't necessarily get smaller. If anything, they could become red giants, which are huge. They do not become brighter because the fusion, the process of hydrogen converting into helium, slows down. Its gravity increases. No, the best answer choice is it becomes cooler. All right, number 8, which of the following galaxies is most like our Milky Way? And that should be an easy one right here. Our Milky Way is a spiral galaxy, period, spiral. Looking at the answer choices in question 8, which answer choice could best be classified as asymmetrical galaxy? A means the opposite of. Symmetrical means that if I cut it in half, pretty much it's going to look the same. It's symmetrical on either side. So asymmetrical means it's not. If I were to cut this straight down, it looks pretty similar. If I cut this straight down, it looks similar. If I cut this straight down, it looks similar. If I cut this straight down, however, this is not. I cannot reflect this and have it look the same. So your answer choice is galaxy B. That is not asymmetrical. Pulsars are dense. They're rotating, and they have a strong electromagnetic radiation with a wavelength of around 6 millimeters. Using the chart below, what type of telescope would be best suited for observing pulsars? Well, I don't even have to know what a pulsar is. I don't even have to know what electromagnetic radiation is. All I have to know is this number right here, which is 6 millimeters. And what type of telescope is best for observing 6 millimeters, and that would be the radio telescope, because it can see greater than 1 millimeter. So your best answer choice was A, which is radio. The other ones are just too small. 11. You hear an astronomer in television mention objects in space is about 10 light years away from planet Earth. This object is located. Well, it's not going to be in my solar system, because halfway to the Milky Way galaxy, and if you remember back here, they gave us a chart that we could go back and use. So that's very helpful to us. So we know the center, at least according to that chart, was 5,000 light years away of our own galaxy. So if it's 10 light years away, I'm going to be on the other side of the Milky Way galaxy. On the other side of the Milky Way, well, that'd be 10,000. So in the solar system, I'm not going to be another galaxy because that's 60 million light years away. Nearby, that's going to be 4.2. It's on the other side, because if it's 5,000 to get to the center, then on the other side, so the answer was C. Okay, let's look at our vocabulary. So, all the mass and energy in existence made up of galaxies and the space between them, that is the universe. The universe is made up of galaxies. Galaxies are made up of stars. Some stars have planets orbiting around them. That makes them solar systems, and solar systems are made up of planets and moons. The distance light will travel in a year, that's light year, traveling at 250,000 miles per second. A system of bodies, planets, asteroids, comets. The clue is revolving around a star, and that is a solar system. The star at the center of our solar system, that's called our sun. A huge grouping of billions of stars that often revolve around a center, that is a galaxy. Remember, galaxies are made up of billions of stars. An instrument used to collect and magnify, that would definitely be a telescope. Tele means far away, scope means to see, telescope to see far away. A massive collection of gases that releases tremendous amount of electromagnetic energy due to nuclear reactions occurring, that's going to be a star. Remember, that's that hydrogen smashing into each other, taking protons, becoming helium, and that's just releasing massive amounts of energy. An interstellar cloud of dust and gas that provides the birthplace for many stars, that's our friend the nebula. Very pretty objects in space. Energy waves sorted by different wavelengths, that would be the electromagnetic spectrum. And we can only see visible light, but there are so many other things out there that our eyes can't even see, and we need machines to help us see that. Well, I hope this helps you. If you have questions, email me or catch me on at Moto, and good luck. I'm very proud of you. All right, bye-bye.